Okay, now that you've collected all your data for the Earth's magnetic field lab, now we'd like to curve fit the data and see what we should have gotten. You will not be able to curve fit this data using my graphing program, so we're going to have to go into Desmos. So open up Desmos, go to where it says the little plus sign, and you want to add a table. In that table, you want to put your angle in one column and your magnetic field strength in the other. You then need to fix the x-axis. Make sure it runs from at least your highest number to your lowest number. And with your y-axis, again, make sure you can include both your lowest number. So I'm -14, I'm going to make mine -20. All the way to your highest number, and for me that highest number is a 60. Make sure you click on degrees. You must be in degree mode when you do this. After you put in all your numbers, I hope you see it's a sine curve, so we'll be adjusting that accordingly. You're going to type in y equals a sine bx plus c plus d, the equation of our sine curve. And you're going to make sliders for each of those possible variables. You're going to adjust the different variables until you get your curve to fit properly. Okay, so let's go through it again. You click on the little plus sign, you click on table. Once you have the table, angles here, magnetic field strength for y. You want to make sure you set up your window so you can see all of your X data points and all of your Y data points, and you want to click on degrees. Okay, hopefully you got a sine curve, so I just wanted to show you. Here's my pocket lab. I'm spinning it around in a circle, and you can see as it goes in a circle, the magnetic field strength varies in a sinusoidal pattern. Okay, here's what it looked like when I collected data very carefully using the pocket lab. Again, y equals a sine bx plus c plus d. Make sliders for them all. Set up your sliders to run similar to what I have here. So a should go from 0 to 60 with a step size of 1. B can go from 0 to 2 with a step size of 0.01. C can go from -180 to +180 with a step size of 0.5. And D can go from 0 to 60 with a step size of 1. I would say adjust them in the order of D, A, B, C. First set up your D, then switch to your A, then your B, and finally your C. Feel free to go back and forth, try and get the fit as best as you possibly can. Okay, then transfer your graph onto your lab sheet. Also transfer your equation. Okay, so here's when I did mine. I got something that looks like this. You're not going to get the same numbers. Okay, but this is what I got. Again, I tried to fit my data so that I had some points above and some points below, matching the shape as best as I could. Okay, and these are my values that I got. So I want to transfer my graph. Again, the y-axis is magnetic field. The x-axis is angle. The magnetic field is in microtesla. The x-axis is in degrees. Okay, the D value for this experiment, I got 31. You're going to get a totally different number. The D value is just based on the internal pocket lab that you used not being zeroed. If we could put our pocket lab in a box that could shield it from all magnetic fields and we could set it to a true 0, then we would have a D value of nothing. But since our pocket lab has not been set up to be zeroed with no magnetic field, there's going to be an offset, and my offset happened to be 31. That D value could be any number, and that number is not going to be something we can give extra credit for. Each pocket lab will give you a different D value depending on when it was calibrated. Okay, the B value is the one you want to do next in terms of talking about it. You'll notice here's a B value of 2, which is clearly wrong. A B value of 2 means that it oscillates twice every time I spin the pocket lab 360 degrees. The correct value should be a B value of 1. It should go through one sine curve for every complete rotation. That one should be a perfect 1. Okay, the A value is the strength of the magnetic field in the room where we took this data. For mine, I have an A value of 17.5 microteslas. And when I check the US Geologic Survey, I should get a horizontal intensity of around 21 microtesla. So I was close, but not perfect. That is not caused by my faulty data collection, but again, I would put that on the calibration of the pocket lab. Okay, finally, the C value. The C value is kind of how much your graph has been offset. Mine came out to around 15 degrees. You see my C value around 15. By having a C value of 15, I peaked not at 90 degrees like a traditional sine curve, but I peaked 15 degrees away from that. About 75 degrees is the peak of my curve. Okay, the reason I don't peak at 90 is twofold. One is kind of weird. Magnetic north does not line up with the true north of our Earth. If it did, we would hit our strongest magnetic field at 90 degrees when we were pointing north. So you can actually on your phone switch it to point to true north or to magnetic north. They are not in the same location. The other problem that leads us to not get a perfect 90 is the fact that Delcy is not quite oriented north-south. So the north wing and the south wing are not perfectly lined up with north and south. They're very close. By combining the amount that the magnetic north is off and the amount that Delcy is off, we can get a true value for our C. I'm not going to tell you what that should be yet. I'm going to wait until all of my data has been collected. Finally, I want to show you a source of error. So you notice my magnetic field strength changing drastically when I bring an electronic gadget near my pocket lab. So in order to get good data, we really should do this lab out in the field with no electronics, no iron or other magnetic materials nearby. Anyway, I'd like you to write up your conclusion with everything other than number 4. I don't want to tell you what the true is quite yet. I will let you know the true value tomorrow, and then you can turn in your lab sheet tomorrow.